Good morning, everyone. Today we are going to start off with the first type of volumetric analysis, that is complexometric titration, which comprises of third chapter of third unit. In the last lecture only, we have gone through basic introductory part of volumetric analysis. That is, what is volumetric analysis, definition of volumetric analysis, types of volumetric analysis, what are the basic apparatus required for performing volumetric analysis, what is the setup and process of volumetric analysis. So today we are going to focus on one class of volumetric analysis, that is complexometric titration. So depending upon the nature of analyte, whether it is acidic or basic, whether it undergoes oxidation or reduction type of titration, whether it contains metal ion in it, whether it contains halide in it, or whether it is insoluble in water, volumetric analysis is categorized into five major classes as seen earlier. That is, if the nature of analyte is if it is acidic or basic in nature, then we are going to perform acid base type of titration. If the nature of analyte it undergoes oxidation or reduction sort of reaction, it comes under oxidation reduction or redox type of titration. If the analyte contains metal ion in it, say for example calcium, magnesium, or aluminum, then we are going to perform the volumetric analysis under complexometric type of titration. If the analyte contains halide atom in it, say for example chlorine, bromine, or iodine, then we are going to perform precipitation type of titration. And if the nature of analyte it is not soluble in water, that is it is weaker in nature, then with the help of organic solvent we are going to dissolve the analyte into anionic and cationic form, and we are going to find out the concentration of analyte by non-aqueous type of titration. So today we are going to focus on the complexometric type of titration. So complexometric type of titration is majorly done for the drug substance that contains metal ion in it. So in complexometric type of titration, mostly the standard solution used is an complexing agent, which is also known as ligand, or which is also known as sequencing agent. So most commonly used standard solution in case of complexometric type of titration is disodium EDTA or ammonium thiocyanate. Mostly disodium EDTA is used as a standard solution. Standard solution is nothing but the solution whose concentration is known to us. And here the concentration of solution used for performing complexometric type of titration is either it is used in a concentration of 0.1 or in concentration of 0.05. So standard solution used in case of complexometric type of titration is the complexing agent, that is disodium EDTA, and it is used in a concentration of 0.1 or 0.05. So standard solution it is usually filled up into the burette. And content in conical flask, since complexometric type of titration is used for determination of the drug substance that contains metal ion in it. So contents in conical flask may be calcium gluconate, it may be either magnesium sulfate, or it may be the drug substance containing zinc as an metal ion, aluminum as an metal ion, or any other. So what is the basic principal part behind complexometric type of titration? It is usually used for the drug substances that contains metal ion in it, metal ion in the form of either calcium, in the form of either magnesium, in the form of either aluminum, zinc, cadmium, and so on. And standard solution used for performing complexometric type of titration, it is also known as ligand solution or complexing agent, and we are using a standard solution in a concentration of either 0.1 or 0.05. Depending upon the nature of analyte, concentration of standard solution is used. Most commonly used standard solution in case of complexometric type of titration is either disodium EDTA or ammonium thiocyanate. Next is the contents to be covered up in this chapter. First content is the classification of complexometric titration, followed by metal ion indicator. That is, what are the indicators preferred in complexometric type of titration. Next is the masking and demasking agent. It is these agents are particularly used for the determination of mixture of metal ions present into an drug substance. That is, if say for example, if the analyte contains two or more than two of the metal ion in it, we can be able to determine concentration of all the metal ions with the help of masking and demasking agent. And last part to be covered up in this chapter is the estimation or assay procedure of magnesium sulfate and calcium gluconate, which comes under complexometric type of titration. So before moving on towards the classification of complexometric titration, let's see what is complexometric titration. So complexometric titration, it is a form of volumetric analysis, that is from the volume of standard solution, that is either disodium EDTA or ammonium thiocyanate, in which the formation of colored complex is used to indicate the endpoint of titration, that is volume of standard solution consumed by the metal ion. We can be able to determine the concentration of metal ion. Here formation, when we are going to add standard solution from burette to contents in the conical flask, what will be the contents in conical flask? It will be the solution of metal ion and indicator. So when we are going to add 1 ml of standard solution from burette to contents in conical flask, there will be formation of complex between the metal ion and ligand entity of the complexing agent. And this complexing agent, formation of complex between these two will have different coloration. That will be the endpoint of titration. And from the volume of standard solution consumed by the metal ion, we can be able to determine the concentration of metal ion. So complexometric titrations are particularly useful for determination of mixture of different metal ions present in a solution. So this is the principal part. That is, the main principle is reaction between the ligand, that is standard solution, and the metal ion to form a complex. So here metal ion acts as an Lewis acid, that is, it is able to withdraw the lone pair of electron from the ligand entity. Therefore, it is known as Lewis acid. And ligand, it acts, ligand means it is a complexing agent, and it acts as a Lewis base, that it donates the lone pair of electron towards the metal ion. Therefore, it is known as Lewis base, which is the complexing agent. So this is the basic principle of complexometric type of titration. So example is the determination of Ag. Ag is treated with the standard ligand or complexing agent, that is ammonium thiocyanate. From ammonium thiocyanate, the cyanide entity will react with the Ag part, and formation of AgCN complex takes place. And this complex is having different coloration. After getting the different coloration, we are going to stop the adding of standard solution from burette, and from the volume of the standard solution consumed by Ag, we can be able to determine the concentration of Ag. So this is the introductory or basic principle part of complexometric type of titration. So what is the basic definition of complexometric titration? Complexometric titration, it is a type of volumetric analysis in which from the volume of standard solution consumed by the metal ion, we can be able to find out the concentration of metal ion. When we are going to add 1 ml of standard solution of complexing agent from burette to contents in conical flask containing metal ion, there is formation of complex between metal ion and complexing agent takes place, and from the color change of this, we can be able to determine the concentration of metal ion. Here metal ion acts as an Lewis acid by accepting a lone pair of electron by from a ligand entity, and ligand entity, it acts as an Lewis base. It donates a lone pair of electron towards the positively charged metal ion. So this is the basic principle of complexometric titration. So depending upon the nature of ligand, that is how many binding sites are present, it is for the ligand or complexing agent is further categorized into unidentate, bidentate, and multidentate. So firstly, we should know what is ligand. So ligand is a species which donates lone pair of electron and forms a coordinate linkage with the metal ion. So it contains excess or surplus amount of electron in it. It will donate it to positively charged metal ion. So formation of complex between metal ion and ligand entity will takes place. So metal ion reacts with the chelating agent or complexing agent, and formation of metal ligand complex or ligand takes place. So formation of complex indicates the endpoint of titration. So depending upon the lone pair of how many binding sites are available, this ligand is categorized into three classes. First class is unidentate. It is a in unidentate ligand or complexing agent. Only single site is present in an on an complexing agent to form a complex with the metal ion. Example of unidentate complexing agent or ligand is the cyanide ion. Second class of complexing agent or ligand entity is the bidentate. In bidentate, two sites are present in complexing agent to bind with the metal ion. An example of bidentate complexing agent or ligand entity is the glycine and oxalic acid. Third type of ligand or complexing agent is the multiple dentate. That is where the name itself indicates multi means more than two or three sites are present for binding of the ligand with that of the metal entity. So most commonly used ligand or complexing agent in case of complexometric type of titration is the multidentate. An example of multidentate complexing agent is the disodium EDTA, that is EDTA. That is, it contains more than two, that is two or three binding sites are available. Therefore, formation of complex will be more stable one. So these are the types of complexing agent or types of ligand. Depending upon how many binding sites are available, these complexing agent are categorized into three major classes, that is unidentate, bidentate and multidentate. Next is what are the chelating agents. So chelating agents, these are nothing. Chelating agents and complexing agents are both the same. So organic molecules containing two or more donor groups, that is they are electron rich one, which combines with the electron deficient metal ion to form complex, and the formed complex will be having a ring structure. And these chelating agents are also known as chelatants, chelators or sequentiating agents. And the most effective chelating groups in ligands are the amino and carboxylate groups. That is basically these two groups will be responsible for attachment of metal ion on it. So other than amino and carboxylate, these are the two chelating agents which are used as complexing agent. That is a dimethyl glycoxime, which contains the nitrogen as a binding site. It does not contain carboxylate group or amino group. Next example of chelating agent other than amino and carboxylate ion is the salicyloxime, which is also a chelating agent other than amino and carboxylate ion. So these are the basic part of complexometric titration. That is, what is complexometric titration? That is formation of complex between the standard solution of complexing agent and metal ion. Next is depending upon the binding site, this complexing agent are further categorized into unidentate, bidentate and multidentate. Mostly in case of complexometric type of titration, multidentate complexing agent is used. An example of multidentate complexing agent is the EDTA, that too disodium EDTA. Next is the chelating agent. Chelating agent are nothing but the complexing agent which donates the lone pair of electron towards the positively charged metal ion, and formation of stable complex takes place. Formation of stable complex will be the endpoint of titration, and this chelating agent or complexing agent basically which donates the lone pair of electrons are the groups containing amino and carboxylate ion. Other than amino and carboxylate ion, dimethyl glycoxime and salicyloxime are the examples of chelating agent which does not contain amino and carboxylate ion. After the basic principle part of complexing agent, we will move on towards the next bit, that is classification of complexometric titration. Depending upon the nature of metal ion, this complexometric type of titration is further classified into 5 basic classes. First class is direct titration. In direct titration, there is formation of direct complex between the complexing agent, which we are going to add 1 ml from burette to conical flask containing metal ion. Only contents required are the solution form of metal ion, indicator and complexing agent. Next type of complexometric titration is the back titration. In back titration, in conical flask itself, we are going to add standard solution of known volume of complexing agent with metal ion and indicator. So second type of complexometric titration is the back titration. In back titration, contents in conical flask will be the solution form of metal. Nextly, we are going to add indicator, and in conical flask itself, we are going to add standard complexing agent, that is diasodium EDTA. So how many quantity of metal ion present in conical flask, that will form complex with the complexing agent, that is diasodium EDTA. And excess amount of disodium EDTA is again back titrated with the standard solution of alkali, which is filled into the burette. So this type of titration is known as back titration. So in case of back titration, contents in conical flask will be the solution form of metal followed by indicator plus excess amount of complexing agent. So जेवढं काय metal ion present आहे conical flask मध्ये, that will react with the standard complexing agent, and excess amount of the complexing agent is then back titrated with the standard solution of alkali, which is filled into the burette. Next, third type of complexometric titration is the replacement titration, and it is particularly performed for the drug substances containing calcium. Say, for example, performance of the assay procedure of calcium gluconate. Calcium is not able to directly form complex with the disodium EDTA. So, firstly, in case of replacement type of titration, we are going to add magnesium sulfate in conical flask, that is contents in conical flask will be the unalloyed, his concentration is to be determined, that is calcium gluconate. Nextly, we are going to add another metal ion, that is magnesium sulfate. Nextly, we are going to add indicator. So this will be the contents in conical flask in case of replacement type of titration. When we are going, since it is an complexometric type of titration, we are going to add 1 ml of standard solution of disodium EDTA from burette to contents in conical flask. So since calcium is not able to form direct complex with the disodium EDTA, so therefore disodium EDTA will firstly form complex with the magnesium entity of magnesium sulfate, and formation of Mg-EDTA complex takes place. When all of the magnesium has been get complexed with the disodium EDTA, then only magnesium has been replaced by calcium, and formation of calcium EDTA complex takes place. So commonly, replacement type of complexometric titration is particularly done for the drug substances containing calcium as an entity. Fourth type of complexometric titration is the alkalimetric titration. So when there is formation of complex between metal ion and complexing agent, acids are liberated. That is, protons are liberated into the conical flask. So the liberated protons are neutralized with the help of standard solution of alkali. So that type of complexometric titration is known as alkalimetric type of titration. That is, liberated amount of protons is then titrated with the standard solution of alkali. Therefore, it is known as alkalimetric type of titration. Fifth type of titration, which comes under complexometric titration, is the indirect titration. Here, indirect titration and replacement titration both are same. When direct complex is not able to form between the annihilate and complexing agent, in that case, we are going to add another metal ion into the conical flask. So formation of complex between Mg and EDTA takes place. When all of the Mg has been consumed by EDTA, excess amount of EDTA will form complex with the calcium. So replacement and indirect type of titration both are same one. So let's see one by one classification of complexometric titration. So first type of complexometric titration is the direct titration. It is the simplest and most convenient method, since direct complex is formed between disodium EDTA and metal ion. No other extra reagent is required. It is simpler and more convenient one. So standard chelating in case of direct titration, the standard complexing agent or chelating agent is added to the metal ion solution until the endpoint has been reached. And in this method, metal ion is added to the suitable buffer solution and appropriate indicator solution, and the resulting solution is titrated with EDTA solution. And the example of the drug substances that comes under direct type of titration is the copper, zinc, and nickel. So these are the three metal substances which comes under direct method type of titration. So in case of direct method type of titration, Contents in burette will be the standard complexing agent, that is disodium EDTA. Contents in conical flask will be the aqueous solution of metal ion. Nextly, we are going to perform all sort of complexometric type of titration in buffer solution. That too we are going to perform in a buffer of pH 10 in order to maintain the stability of the complex which is formed between the metal ion and complexing agent. So contents in conical flask will be the metal ion. For dissolving purpose, we are going to use appropriate solvent. For maintaining the pH, we are going to maintain the pH at 10 in order to maintain the stability of complex which will be formed between the metal ion and complexing agent. And lastly is the indicator. Depending upon the nature of metal ion, indicator is selected one. So in case of direct titration, the contents are directly titrated with the disodium EDTA, and from the color change of the indicator indicates the endpoint of titration. That is, no more metal ion will be present in conical flask with the standard solution of complexing agent. That will be the endpoint of titration, and color change of the solution in conical flask will be occur. At that moment, we will stop the addition of standard complexing agent from burette to contents in conical flask, and from the volume of complexing agent consumed by the metal, we can be able to determine the concentration of the metal ion. What is the disadvantage of this direct method? That is, time consumption is more as compared to other methods of complexometric titration, and also the interference of other metal ions can be observed one. So this is the disadvantage of direct method. Advantage ka, it is simpler and convenient one. We just have to prepare aqueous solution of metal ion. We just have to maintain the pH at 10, and we need to add the indicator. This will be the contents in conical flask, and rough wise we are going to add standard solution from burette to contents in conical flask. When we are going to add standard solution of complexing agent from burette to contents in conical flask, formation of complex between the two, that is metal ion and complexing agent, takes place, and color change of the solution takes place. At that moment, from the we will stop addition of standard solution from burette, that is complexing agent, to contents in conical flask, and endpoint can be determined. But this process is very lengthy one. That is, since it does not involve any sort of extra reagent, time required for the annihilator, time required for the metal ion to react with the complexing agent will be more one. Therefore, more standard solution will be consumed by the metal ion. So this is the disadvantage of direct method of titration. Second method of complexometric titration is the back titration. In this method, excess of complexing agent is back titrated with the standard solution of second metal ion. So for example, we are going to determine the concentration of zinc, either in zinc chloride, either in zinc sulfate. So firstly, we are going to prepare solution of zinc chloride. Nextly, we are going to maintain the pH at 10 in order to maintain the stability of complex which will be formed between metal ion and complexing agent. Nextly, we are going to add indicator. And lastly, we are going to add standard solution of EDTA in conical flask itself. Then when we are going to add standard solution of complexing agent into the conical flask, then zinc will react with the complexing agent, that is EDTA, and formation of complex between zinc and EDTA will takes place. An excess amount of EDTA is then back titrated with second metal ion which is filled into the burette. So जेवढं काय झिंक प्रेझेंट असेल त्या कोनिकल फ्लास्क मध्ये दॅट विल रिॲक्ट विथ दी कॉम्प्लेक्सिंग एजंट, दॅट इज EDTA. आणि नंतर जेवढं काय अनरिएक्टेड पार्ट आहे डायसोडियम EDTA that is then back titrated with the second metal ion. So in this method, excess of standard EDTA solution is added to the sample solution. pH is adjusted to 10. Then the resulting solution, after maintaining the pH, formation of complex between the metal ion and EDTA will be takes place, and then the resulting solution, which is that is the unreacted part of EDTA, is back titrated with the appropriate titrant. So depending upon the nature of annulate, appropriate titrant is selected one. So example of the drug substance which comes under back type of titration is the zinc chloride, zinc sulfate, magnesium chloride, magnesium sulfate. So these are also used as a standard solution. Next is the metal ion which can be determined by back type of titration is the aluminum, cobalt, lead, manganese, mercury, and nickel. So these are the example of the metal ion which can be determined by compact type of titration. Third type of complexometric titration is the replacement titration. The name itself indicates that is displacement of the metal ion with other metal ion takes place in this method, but it does not give the sharp endpoint. Example is the formation of complex between the firstly magnesium sulfate and EDTA. When all of the magnesium sulfate has been consumed by EDTA, the Mg-EDTA complex will be replaced by another entity. Here we have seen example of manganese. Say for example, if we are going to perform replacement type of titration for manganese, so contents present in conical flask will be the solution form of manganese. Next is known amount of magnesium sulfate. Next is for maintaining the pH 10, we are going to use appropriate buffer. Next is the indicator. Nextly, we are going to add 1 ml of standard solution of complexing agent from burette to contents in conical flask. During addition process, there is formation of firstly complex between the magnesium entity of MgSO4 and complexing agent, that is EDTA. Formation of Mg-EDTA complex takes place when all of the MgSO4 has been consumed by EDTA. Then this Mg-EDTA complex dissolved and this Mg has been replaced by Mn, and formation of Mn-EDTA complex takes place with the liberation of free manganese. So this comes under replacement type of titration, and endpoints obtained from replacement type of titration are not accurate one. Therefore, this method, this type of complexometric type of titration is not preferred one. Next is the alkalimetric type of titration. This method uses the principle of liberation of free H plus ion during the complexion. Whatever the type of titration, it may be direct, indirect, replacement, alkalimetric. In that case, when there is formation of complex between this complexing agent, that is EDTA, and metal ion, H plus or protons are liberated. The liberated H plus proton are titrated with the standard solution of alkali. So that comes under alkalimetric type of titration. Other than standard solution of alkali, we can also determine the concentration of H plus by instrumental method of analysis. This is the last type of complexometric titration, that is indirect method of titration. In indirect method of titration, the protons which are liberated by formation of complex between the complexing agent and metal ion are displaced by the heavy metal and titrated with sodium alkali. An indirect method of titration is particularly used for determination of the metal ions, that is sodium, potassium, Ag, Au, As, Cl, Br and S. So in case of indirect method of titration, the the complexing agent, that is here we will this is the symbolic representation of complexing agent, that is H2X. So this complexing agent will react with the manganese entity or metal ion, and formation of MX complex takes place, and H plus acid is liberated. The liberated H plus or protons are treated with the standard solution of alkali. So alkalimetric type of titration and indirect method of titration are near about same. That is, metal ion reacts with the complexing agent, formation of complex takes place with the liberation of acid or with the liberation of proton. The liberated proton is treated with the standard solution of alkali, either it may be sodium hydroxide, and the formed H plus or formed protons are neutralized one. So these are the 5 classes of complexometric titration. First class is the direct titration. In direct titration, we are going to directly treat the metal ion with complexing agent. Formation of complex takes place, and the endpoint can be determined by the color change of the contents in conical flask. Color change occurs at the moment when all of the metal ion has been consumed by the EDTA and for stable complex has been formed between two. And all sorts of complexometric titrations, we are going to perform it in a pH of 10. By we can be able to maintain the pH at 10 by the use of appropriate buffer. So in case of direct titration, we are going to directly treat the metal ion with complexing agent. No more extra reagents are required. Only metal ion, indicator and buffer is required in conical flask, and 1 ml of complexing agent we are going to add into the from burette we are going to add it into the conical flask, and endpoint has been reached one. Second type of complexometric titration is the back titration. In back titration, in conical flask itself, we are going to add standard complexing agent. Then the metal ion which is present in the conical flask, that is how many quantity of metal ion present in conical flask, that will react with the complexing agent, and excess amount of the complexing agent is then back titrated with the second metal ion standard solution, that may be either zinc chloride, zinc sulfate, magnesium chloride or magnesium sulfate. So this is known as back titration. So what is back titration? Firstly, we are going to treat the metal ion with excess amount of complexing agent. Then जेवढं काय metal ion present असेल त्या conical flask मध्ये, that will react with the complexing agent, that is diazonium ADTA, and the remaining that is unreacted part of the complexing agent is then back titrated with the second standard metal ion solution. Third type of complexometric titration is the replacement titration. The results given by replacement titration are not accurate as compared to other type of complexometric titration. In replacement type of titration, firstly there is formation of complex between one metal ion and EDTA, and after formation of complex, the first metal ion has been replaced by the another one. So the name itself indicates it is a replacement of one metal ion with that of the other one. Next is alkalimetric titration and indirect type of titration. In both alkalimetric and indirect type of titration, when metal ion reacts with the complexing agent, formation of complex with the liberation of acid or with the liberation of proton takes place. The liberated proton or acid is then back titrated with the standard solution of alkali. So this is the second part of complexometric titration, that is classification. Moving on towards the third part of complexometric titration is the metal ion indicator, that is which indicator is used in case of which type of metal ion. So firstly we will study definition of metal ion indicator. What is metal ion indicator? So metal ion indicator is nothing but it is a substance that changes color when it binds to metal ion in a solution. So firstly, contents in conical flask and complexometric type of titration will be the solution of metal ion. Nextly, for maintaining the pH 10, appropriate buffers are used. And lastly, we are going to add the indicator. After addition of indicator, there is formation of complex between the indicator and metal ion. But when we are going to add complexing agent from burette to contents in conical flask, the complex between metal ion and indicator will dissociate out or breaks up, and formation of complex between metal and complexing agent takes place. Due to the dissociation of complex between metal ion and indicator, there is change in color of the contents in conical flask takes place. That is formation of complex between metal and indicator will break up, and formation of complex between metal ion and complexing agent takes place. That determines that whole of the metal ion has been set free from the indicator and it has been reacted with the standard solution of complexing agent. So example of metal ion indicators used in complexometric type of titration is the erichrome black, muric zir, xylitol orange, and pyridyl azonaphthol. So these are the indicators used in case of complexometric type of titration. So what are the requirements of these metal indicators used in complexometric type of titration? So first requirement of metal ion indicator used in complexometric type of titration is the color of indicator must be sufficiently intense so that a minimum amount of indicator can be used. So the indicator of color which is used for determination of endpoint of titration in any sort of titration, that too in complexometric type of titration, it should be intense one or it should be dark one, so that little quantity of indicator will give a color to the aqueous solution of metal ion. Second requirement of metal ion indicator is the color contrast between the indicator and metal indicator complex should be readily observable. Say for example, firstly if we are going to take only aqueous solution of metal ion, nextly we are going to add buffer solution, lastly the color of contents in conical flask will be different one. That is, it contains only metal ion and buffer. After addition of the indicator, that is complexometric indicator to contents in conical flask, color change should be occur. That is, it should be contrast or it should be different. That is, color of metal solution, it should be changed one. This color change particularly occurs due to the formation of complex between the metal ion and indicator, which is used for titration purpose. So what is the first required? The color of the indicator, it should be dark or it should be intense one. That is, plain indicatorचा color हा dark किंवा intense असायला पाहिजे, so that little quantity is sufficient for determining the endpoint. Nextly, when we are going to add the indicator to solution of metal, there should be a formation of complex between these two, and formed complex should have a different or contrast coloration. Third requirement is the metal indicator complex should possess sufficient stability to ensure a sharp color change. However, it should be less than metal EDTA complex. That is, whatever the complex which will be firstly going to form between the metal ion and indicator, the formed complex should be stable one, but its stability should be less as compared to the stability of complex which will be going to form between metal ion and complexing agent. Initially, contents in conical flask will be only metal, buffer, and indicator. So when we are going to add indicator, formation of complex between metal and indicator is going to take place, and the formed complex should be stable one. But when we are going to add 1 ml of standard solution from burette, that is complexing agent, to contents in conical flask, stability of complex between the metal ion and indicator, it should be dissociate one, or it should break easily, and formation of complex should occur between metal ion and EDTA. That is the main aim of complexometric titration, that is formation of complex between metal and EDTA. So formed complex between metal and indicator should easily dissociate, and formation of complex between metal and EDTA should occur after addition of complexing agent from burette to contents in conical flask. So this will be the third requirement of complexometric titration. Next, fourth requirement, the change in equilibrium from metal indicator complex to metal EDTA complex should be sharp and rapid. That is, dissociation of complex between metal indicator and formation of complex between metal EDTA should be sharpened, and it should be rapid one. Due to the change in complex between metal indicator and formation of complex between metal EDTA, the color change should be sharpened and it should be rapid one. Next is the color reaction of indicator should be selective one. Depending upon the nature of which metal ion we are going to identify, the selection of indicator should be selective one. Next, the indicator must be very sensitive to metal ion so that color change occur at near the equivalence point. So it should, the chosen indicator, it should be highly selective one, and it should be highly sensitive one, and it should sharply determine the endpoint of titration. What is the endpoint of titration in complexometric type of titration? That is utilization of whole of the metal ion which is present in conical flask by complexing agent. So indicator should sharply indicate the endpoint of titration. Seventh basic requirement of metal ion indicator is the indicator must be stable in titration media. It should not undergo deterioration. So stability of chosen metal ion indicator, it should be highly stable one. It should not undergo any sort of decomposition. Next is the indicator must be stable on storage also. If you are going to prepare the solution form of indicator for a longer period of time, so on storage, it should not undergo any sort of decomposition. So stability of formed solution of indicator, it should be high one. Next, all the above requirement must be filled in a pH range in which the proposed titration is to be carried out. So जे काय आपण पूर्ण titration मध्ये pH required maintain करणार आहे, depending upon the nature of analyte, pH may get vary. It may be either 9, it may be either 10. So metal ion should fulfill all the requirements in determined pH, and it should be commercially available in adequate purity. That is, availability of indicator, it should be easily available one, and it should be along with availability, it should be highly pure one. That is, it should not contain any sort of impurity. So these are the requirements of indicator used in complexometric type of titration. Next is the example of indicators used in complexometric type of titration. So first indicator used in complexometric type of titration is the Erichrome black T, that which is also known as capital EBT, and it is basically used for determination of metal ions, that is Mg, Zn, Mn, Cd, Hg, Pb, Cu, Al, iron, nickel, cobalt, nickel, platinum, metal ions, etc. So these are the metal ions by which, so for the determination of metal ions, that is Mg, Zn, Mn, Cd, Hg, Pb, this EBT, that is Erichrome black T indicator, is selected. Next indicator used in complexometric type of titration is the Murixid, and it is particularly used for the estimation of the metal ion, that is calcium, nickel, cobalt, zinc, cadmium, and copper metal ions in EDTA titration. Third type of metal ion indicator used in complexometric type of titration is the xynolol orange, which is used for determination of the metal ions, that is Bi, Cd, Pb, Sc, Kh, zinc metal ions in EDTA titration. And last type of metal ion indicator used in complexometric type of titration is the pyridyl azonaphthol, which is also known as PAN, which is particularly used for determination of the drug substances containing metal ion either in the form of Cd, Cu, iron, Sc, or Zn. That too particularly in back and replacement type of titration. So these are the four types of indicators that are particularly used in determination of specific type of metal ion indicator that comes under complexometric type of titration. So first part of complexometric type of titration contains principle of complexometric type of titration. So what is the principle of complexometric type of titration? In complexometric type of titration, there is formation of complex between complexing agent, which is usually filled up into the burette, and metal ion, which is usually filled up into the conical flask. So contents in burette will be for performing complexometric type of titration. Commonly used complexing agent is disodium EDTA or ammonium thiocyanate. That too, it is used in a concentration of either 0.1 or 0.05. Contents in conical flask in complexometric type of titration is the aqueous solution of metal ion. Nextly, for maintaining the pH at 10, we are going to use appropriate buffer. Nextly, we are going to use metal ion indicator. So this will be the contents in conical flask. When we are going to add drop-wise standard solution from burette to contents in conical flask, there is formation of complex between the complexing agent and metal ion, that is Mg-EDTA complex takes place with the liberation of proton, that is H+. So this is the introductory part of complexometric titration. After introductory part, we have covered classification of complexometric titration. So depending upon the nature of analyte, complexometric titration is categorized into 5 major classes: direct, back, replacement, alkalimetry, and indirect. Indirect titration, directly we are going to titrate the solution of metal ion with complexing agent. In back type of titration, we are going to treat the metal ion with excess amount of complexing agent, that too in conical flask itself. Unreacted or remaining part of metal complexing agent is then back titrated with the second metal ion. Third type of complexometric titration is the replacement titration. Replacement titration is particularly done for the drug substances containing calcium or manganese. In case of replacement type of titration, firstly there is formation of complex between second metal ion and EDTA. After getting the endpoint of titration between second metal ion and EDTA, second metal ion has been replaced with the first metal ion. That comes under replacement type of titration. Next, fourth, that is alkalimetric, and fifth, that is indirect type of titration. Both are near about same. That is when there is formation of complex between metal ion and complexing agent. Protons or acid is liberated. The liberated acid or proton is neutralized with the help of standard solution of alkali. So we have studied one by one all the 5 types of complexometric titration, and the example that comes under it. After the classification of complexometric type of titration, we have gone through the indicators used in complexometric type of titration. So indicators used in complexometric type of titration are also known as metal ion indicator. So firstly, in complexometric type of titration, there is formation of complex between metal ion and indicator. And when we are going to add standard solution from burette to contents in conical flask, the formed complex between metal ion and indicator will get dissociated out or separated out, and formation of complex between complexing agent and metal ion takes place, and that is indicated by the color change in contents in conical flask. That will be the end point of titration. So depending upon the after what basic part of metal ion indicator, we have covered requirements of metal ion indicator. After the requirements of metal ion indicator, we have covered the examples of metal ion indicator, that is EBT, murixid, xylitol orange, and pyridyl azonaphthol. That is which metal ion indicator is used in which metal ion indicator is used in determination of which metal ion. Next part of complexometric type of titration is masking and demasking agent. So particularly masking and demasking agent in complexometric type of titration is usually used for determination of the metal ions containing either two or more than two metal ions present in an analyte. So for example, if in a conical flask, if we contain, if say for example, so what are masking and demasking agent? Masking and demasking agent are usually used for determination of the drug substances that contains two or more than two metal ions. So firstly, we will study what are masking agent. So definition of masking agent. Masking agent is an reagent used in chemical analysis which reacts with the chemical species that may interfere in the analysis. So masking agent are nothing but the substances that will mask or that will cover the unwanted metal ion present in a given substance, that is which is not required for titration purpose. So masking and demasking agent are used for the determination, are used for covering